First, I want to welcome you to everybody in Basel. My presentation will be about the GPUs usage at the University of Basel. For 2 years, we had to renew the whole hardware and the whole infrastructure that we had at the university. And at this time, it was the hype, more or less, about GPUs. Should we use or should we not use the GPUs? And how many GPUs should we install? And we just show what we decided and how we implemented them. Okay, so first we will just have the motivation why we did use of GPUs. And we will have a look at the infrastructure that we bought to run the cluster and with the GPU environment and the software environment. Then we will have a look how we integrated the GPUs in the batch queuing system, how we monitor these GPUs, and even how we report what's going on with GPUs. And we have a short look at the results that we get with these GPUs for the performance and even for the efficiency. And then we have a short conclusion. Okay, why did we bought some GPUs for 2 years? One of the reasons was we wanted to increase the power computing. We wanted also to meet the future needs from our customers who need every time more and more power computing. There is also a very important reason. There is a big TFT project, that's an European project, and there is one group from the university who is actively participating and developing code for this project. And one of the goals of this project is to port the code to GPUs. That's more or less already done now. We want also to lower the acquisition costs because GPUs are cheaper. Reduce the power and the cooling consumption. That's our big problem. We have not enough cooling in the university for all our equipment. And that's more or less self-satisfaction. We want to try new technology. Okay, for 2 years, we renewed the whole cluster, and now that's the actual architecture of our cluster. First, we can see that the whole thing is in 2 different rooms. Here we have a room Bernoullianum, room UB, and both rooms are separated by about 200 meters. So we are not able to put one cluster in only one room. We have normal nodes, different because we have 8 cores to 12 cores, because these ones were acquired for 2 years, these last years. We have a master, we have an NFS file server and a parallel file server. And we have a GPU environment. We'll have a look later how it is configured and what's inside. Then on the other room, we have also normal nodes and 12 nodes with GPUs. Whole thing is connected through Ethernet or InfiniBand, but we have no InfiniBand connection between both rooms. Okay, now we will have a look at the environment within the first room. We bought at this time 8 nodes, and with each one GPU. So we have the node, that's in the 1U server, with 2 quad-core and 1 GPU. They are both connected through Ethernet and every time through InfiniBand. When the physics, this one needed it to develop and to try the big TFT code, and they needed more power. So they bought at this time 12 nodes and 24 GPUs. And we have here 4 servers in a 2U chassis. On each side we have 1 server, and over that we have 4 NVIDIA cards, where every time connected, one's on this server and one on this server. And we have 3 of these environments to get the 24 GPUs and the 26 cores. For the software, we decided that every node has to have same configuration. We want not to make any difference between GPUs and or non-GPU cores because we wanted to mix the software and everything. For the operating system, we are now on CentOS 64-bit 5.5. For the queuing system, we now use the OpenGrid scheduler, the latest version. The compiler, we use principally Intel, GNU, and for one reason, for one software, we need the PGI compiler. For libraries, we principally use OpenMP and OpenMPI and OpenMP for some reason. And then for CUDA, or for the graphic cards, we use the CUDA toolkit, at this time version 3.2. And for OpenCL version, we are at 1.0. And we have, at this time, these applications who are running and are compiled for GPUs. We have NumD, BigTFT, that's our main program, and also MATLAB, which is running now with GPUs. Okay, we will have now a look how we integrated the GPU in our cluster. As I told you, every node has the same configuration, but we had to make some differentiation for the GPUs. So how we integrated in is SGA. First, we have no program which is just running on GPUs. So we tied a GPU with one core. That means when we run a program, it's running on one core, GPU. So to control the access to the GPU, we make the following. We create a force complex in SGA. We create a queue, and with one slot for each node, and we assigned the force complex to this queue. That means that the people who want to use this queue have to use it with the queue name and with the force complex. That's the only way to come in the queue. And that was very important. We had to instruct the people to use this command to use the GPUs. But we have every time a lot of people who are not able to understand that. So we also created a submit script for each application where we generate and put all these options when we submit the scripts. So one of the things that we wanted also to do is to monitor, do the people use or don't they use the GPUs. For 1 year, we were totally blind. We didn't know what's happening, what's going on, because we had no possibility to get any activity on these GPU cards. But since CUDA version 3.2, they also bring a new system management interfaces. And with these management interfaces, we have now the possibility to have a look into the GPUs. When we use this command here, he puts out the CPU usage and the memory usage. And when you run it with a Linux loop and get the statistic every second, you can see exactly what's going on. So we use this output and put it back to Ganglia with this command, with Gmetrics. And now we have the possibility to have a graphic, what's going on our GPUs. That's just for 2 hours what's going on. And we see the different load. And we also see that we don't use a lot of memory here. Okay, we want also to have some reporting about the GPUs. And for a moment, we have no explicit reporting in SGE. We are not able to report what's going on with these GPUs. We don't know the GPU usages and the memory usages. So we don't know what's going on, and we cannot report is it very used or not heavily used. The only thing that we have for a moment is that we can see how many jobs were there by just selecting the jobs we were running on these queues. And the other possibility that we use for a moment to get the usage is that we go directly in Ganglia to see what's going on in the next month. And here we see immediately that, okay, before we hadn't the possibility because we had the old version from the driver and we had not the possibility to get any statistics. But we can see we had a short peak here, but 3 months there was going nothing, and now the people are coming and calculating on the GPUs. This is the CPU, the URZ part. The physics part, it's a little bit different because they will use big TFT code and they not go necessarily through the SunGrid engine. They don't every time use the scheduler, so we have not the same possibilities. But they use more often the GPUs than we do. Okay, we also wanted to know, are they efficient with GPUs? So we made some performance tests. We just limit us on one program, NumD2, and we made a comparison between poorly CPU or GPUs. And we run it in different number of processes. We have every time 2 CPUs or 2 GPUs, and 4, 8, 60, 32. Where I had not enough GPUs to test it. And we can see the time that it takes in hours to execute with 2 CPUs and 2 GPUs. And we can see that we are at least 5 times faster with GPUs than we are with GPUs, with CPUs.
The CPUs are what core?
No, that's one core.
One core.
Yeah, it's every time when we speak about CPU, it's just one core. And as I told you, we have, with NumD2, for the moment, we are 5 times faster. That can change in the next time because NumD is porting the code continually on GPUs, and every time there are more and more part of the code we ported. So we will be in the near future, we should be faster. And for the physics group where we develop a big DFT, they are now at another range. They are 8 times faster when they use the GPUs than the CPUs. So then we wanted just to have a look what's going on when we are running. What's every time with the same program, NumD2, and we have a look what's going on with GPU when we are using and calculating. And we can see that the peak here is 40%, and the average is between 25 and 30, depending on what kind of input file we have. So we are, for a moment, not able to use the full power from the GPUs. And when we wanted to have a comparison, what's going on, to compare 2 quad-core with 1 GPU, which is faster. And here it took 8 CPUs and compared it with a GPU. And we can see, for a moment, in this case, and we are faster with just 8 core than with 1 GPUs. And it's exactly the same, in the same relation when we use it with 60 CPUs or 2 GPUs. Now the question is, why are we so inefficient here? Because we don't use the whole power that we got from the GPU. There are different possibilities. One is certainly because we have to put the memory, the structure from the main memory to the GPU memory, to put it back to the main memory, and we lost a lot of time. And the whole reason is certainly also because the job is not enough parallelized. Okay, for conclusion, what can we say about the GPUs? They are very powerful, and they reduce the execution time from our programs. The problem that we have is that we need highly parallel code to deliver the speed, and that's not necessarily every time the case. The other problem is that the programs need to be ported or rewritten to use the power from the GPUs. There is also another problem. The user must learn a new language to use with GPUs and to program with GPUs. And that's also one of the problem. It suits only for massively parallel application because there are a lot of small parallel processor and a high number of processors in these graphic cards. And to use the power, you have to use all threads, and that's not necessarily the case in our application for the moment. Okay, that's just a short overview what we are doing and how we are using the GPUs at the university.